Hey everybody, it's Mr. Bennett. It's back with a new video. We haven't done one in a while. We've been kind of sitting on Newton's laws for a little bit, and now we're ready to move on. We've looked at forces, we've looked at motion, we've talked about all kinds of different things, and now it's time to throw energy into the mix. So stuff doesn't move without a force. Forces don't really occur without energy being transmitted somewhere. And this also includes things like work and power, but we're not going to talk about them so much. We're really going to stick to the energy side of things. And to get into this, we need to look at two divisions, or the division of types of energy. So we're going to look at the difference between potential energy, which is stored energy, and kinetic energy. So potential energy could be something like a ball suspended in the air, or it could be even the energy held between the atoms of a water molecule. There's a lot of different ways, but we're going to talk in broad terms right now. There's a specific one we're going to mention, and this is potential energy due to gravity. And this is called gravitational potential energy, gravitational PE. And we simplify this even more as GPE. So when we talk about GPE, we mean potential energy due to gravity. So let's take a look at a couple examples. So the source side on the left, we're going to do potential energy. We're going to draw a picture, do a quick calculation. If you can multiply and divide, you're all set. So on the left, I'm going to draw a table, a really small little end table, and we're going to have a ball on that end table, and the end table is sitting on the ground. So right now this ball is suspended in the air. It has gravitational potential energy. The equation we're going to use, so GPE is equal to the mass of the object times the acceleration due to gravity times the height of that object. So this is looking at what energy the ball has due to the fact that it's not moving downwards yet. It has potential to do something. So if we have a ball, let's say its mass is 4 kilograms, 4 kilos. Let's say the gravity, or not let's say, but the constant, remember this is a constant, this is 9.8 meters per second squared. And then the height of this object, we'll say, I don't know, 2.5 meters. So if this is 2.5 meters up, this ball weighs 4 kilos, that's roughly 10 pounds ballpark, and gravity accelerates it, we can calculate its potential energy. So GPE equals 4 times 9.8 times 2.5, and the order doesn't matter, but this works out to 98, and we need a new unit. So if you look down here towards the bottom of your screen, the unit for energy is called a joule. This is a new unit, so this is 9.8 joules with a J. So that's the gravitational potential energy of that ball. On the other hand, if we do kinetic energy, let's draw a simple table again. So we're going to look at this ball. Somebody comes by and knocks that ball off the table. So if I go over, and we're going to keep it that, and now the ball is falling. Oh no. The equation that we're going to use for kinetic energy, the way we do this is energy kinetic, EK. This is equal to 1/2 the mass times that object's velocity. So 1/2 mv, and we square that velocity. So 1/2 mv squared is the equation that we will be using. So over here on the left, let's keep our mass the same. So mass is 4 kilograms. And let's say its velocity, it's not quite up to 9.8. Let's say this is, I don't know, 3 meters per second squared. So with this data, we can take this, and remember EK, so kinetic energy, this is equal to 1/2 times the mass of 4 times the velocity, 3.0, and that velocity is squared. So 3 times 3 is 9, 9 times 4 is 36, and we need to do that divided by 2. So 36 divided by 2 gives me 18. So 18, and remember, the unit of energy is the joule. So this gets the joules after it, J, joules. So we can calculate potential and kinetic energy. You need to know how to use these equations. When we look down, remember, potential energy is not only determined by gravity. I mentioned at the top that something like a coiled spring has a potential energy. It can do something. Gravity is just the easiest way to start to make this connection. We're going to be looking at all kinds of different types of energy. To get you started, remember, there's always these critical thinking questions. You can also feel free to leave a question in the comments. I will take a look at that, and I can answer that either in a separate video, or I'll just write back to right back to you. And as always, you can find the worksheets, the paired papers with this at bennettscience.co. Thanks for watching. I'll see you next time.